and welcome to the mathleague YouTube channel. The following video was recorded by one of our staff members live at one of our contests.
I'll show you how to do target number 5. So here we go. And let's read through. In rhombus ABCD, I'll be drawing it meanwhile. Here is our rhombus ABCD. We are given that AB is equal to 26, so all of these side lengths are 26. And AC is equal to 20. Then we have point E somewhere on AC, so that AE is equal to 3. And line BE intersects AD at point F. Then we want to find the length BF. Okay, so how do we approach these length problems? Let's go ahead and try to find a way to find the length of BF. So one way we can consider is splitting BF into the lengths BE and EF. So what kind of approach could work so that we could find those lengths? Well, provided we know BE, we can then find the length EF by these two similar triangles eventually, but we'll get there soon. And to find BE, what do we do? Well, in order to take advantage of this length over here and this triangle ABC, we can consider dropping the altitude since this is an isosceles triangle, and then trying to use the right angle and Pythagorean theorem from there. So what happens if we drop this angle here? Well, this altitude. Well, this altitude splits this length into two parts, equal parts that is, with length 10 here and length 10 here. So that's why it's nice to drop the altitude and create a right angle here. So then, by using Pythagorean theorem or recognizing Pythagorean triples, this is a scaled up 5, 12, 13 triangle. So this is an altitude of 24. And what this gives is, since we can find this length here, which is 7, because that's 3 plus 7 equals 10, we can use the Pythagorean theorem again, or Pythagorean triples, to find the length of BE. So that's a 7, 24, 25 triangle. So BE is equal to 25. Okay, now we want to find EF. And since these side lengths here are parallel, and these are vertical angles like this, and these angles across are equal, we have the following similar triangles. AEF is similar to CEB. Okay, now to access this length EF, this corresponds to the side length BE. And then we want to find two other side lengths that we know to get the ratio. That would be, we don't quite have AF, but we do have AE, which is 3, and we have CE, which is 7 plus 10 equals 17. So our ratios are EF, what we want to find, over BE is equal to AE over CE. And just substituting the lengths in, we get EF over 25 is equal to 3 over 17. So EF is equal to 75 over 17. Finally, we just add these together, BE and EF, in order to get the length BF. BF is equal to BE plus EF. It's equal to 25 plus 75 over 17, which is equal to 500 over 17. And we want to compute the sum of numerator and denominator. This is 500 plus 17 is equal to 517.
Hi everybody, this is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.